Hey everyone, welcome back. Today, we're breaking down one of the biggest buzzwords of our time, artificial intelligence. No deep technical rabbit holes, no confusing math, just a simple, clear explanation of how AI actually works, whether you're technical or not. By the end of this video, you'll understand what AI, machine learning, and generative AI really mean. Let's get into it. Here's what we're going to cover. First, what AI actually is in plain English. Then how AI, machine learning, and deep learning relate to each other. We'll look at how machines learn from data, peek inside neural networks, understand how tools like ChatGPT actually write, and finally, decode the key jargon so none of it feels intimidating anymore. So, what is AI, really? At its core, AI is just software that performs tasks which normally require human intelligence. That includes recognizing things, like a face or a voice, deciding between options, predicting what might happen next, and even creating brand new content, like text or images. That's it. No sci-fi robots required. And here's the thing. AI isn't some futuristic concept. It's already part of your everyday life. When Siri or Alexa understands what you say, that's AI. When Google Maps predicts the fastest route, that's AI. Your Netflix recommendations, your spam filter, unlocking your phone with your face, even chatting with a customer support bot, all AI, quietly working in the background. Now let's clear up one of the most confusing parts, how AI, machine learning, deep learning, and generative AI relate to each other. Think of it like a set of nesting dolls. Artificial intelligence is the broadest goal, any machine that acts intelligently. Machine learning is one way to achieve that, by learning from data instead of following fixed rules. Deep learning is a powerful type of machine learning that uses many layered neural networks. And generative AI is deep learning applied to creating new content, text, images, audio. Each one sits inside the last. Here's the single biggest shift to understand. In traditional programming, a person writes the rules by hand. You feed in rules plus data, and the computer spits out answers. Machine learning flips that completely. You feed in data plus example answers, and the computer figures out the rules on its own. Those learned rules are what we call the model. That flip from writing rules to learning them is the whole revolution. So, how does that learning actually happen? Think of it as a three-step recipe. Step 1, you need data. Thousands, sometimes billions of examples. Step 2, training. An algorithm sifts through that data, looking for patterns. Step 3, out comes a model. Basically, the pattern the computer discovered, saved as a big set of numbers. Once you have that model, you can feed it brand new input it's never seen, and it produces a prediction. Not all learning happens the same way, though. There are 3 main styles. Supervised learning uses labeled examples, like emails already tagged spam or not spam, to teach the system the right answer. Unsupervised learning has no labels at all. It just finds hidden patterns, like grouping similar customers together. And reinforcement learning is trial and error with rewards. Think of an AI that gets better at a video game by trying to maximize its score over time. Let's talk about the word model, because it gets thrown around a lot. Think of a model like a recipe the computer writes for itself. Not because someone told it the steps, but because it tasted thousands of dishes, or examples, until it could recreate that flavor on its own. Technically, a model is a giant set of adjustable numbers, called parameters, and the scale is wild. Modern large language models have hundreds of billions of these parameters. Now let's peek inside one of the most talked about structures in AI, the neural network. Data goes in through an input layer, passes through one or more hidden layers where patterns get combined and refined, and comes out through an output layer as the answer. It's loosely inspired by neurons in the brain. Every connection between nodes has a weight, a number that strengthens or weakens the signal. Training is really just the process of adjusting all those weights. So, how does training actually adjust those weights? It's a loop repeated over and over. First, the model makes a guess. Second, that guess gets compared to the correct answer. Third, the system calculates the error, how far off the guess was. Fourth, it nudges the internal numbers slightly to reduce that error next time. Then it repeats, often millions of times. It's exactly like a student grinding through practice tests, checking answers, and slowly improving. Now for the part everyone's curious about. How does something like ChatGPT actually write? It starts by training on a massive amount of text. Books, articles, websites, code, billions of pages. From that, it learns statistical language patterns, which words tend to follow which other words. Then, when you give it a prompt, it predicts the single most likely next word, adds it, and repeats the entire process again for the following word, building a full response one prediction at a time. Look at this example. The cat sat on the... Based on patterns in its training data, it calculates probabilities. Mat at 71%, floor at 14%, and picks the top one. That's fundamentally what's happening under the hood, just at a massive scale. Let's decode some of the jargon you'll hear constantly. An algorithm is just a step-by-step method. Here, the method used to learn from data. A data set is the collection of examples used to teach or test a model. Training is the process of showing the model examples so it can improve. And parameters are the internal numbers the model adjusts. Essentially, it's learned knowledge. A few more terms. A model is the trained result, the patterns saved as parameters, ready to make predictions. Inference is simply using that trained model on brand new data. A neural network is that layered structure, loosely inspired by the brain. And bias refers to skewed or unfair patterns a model can pick up if its training data itself was imperfect or unbalanced, a really important thing to keep in mind. Before we wrap up, let's bust a few common myths. Myth: AI thinks and understands like a human. Reality: it finds statistical patterns in data. There's no consciousness or true understanding involved. Myth: AI is always right. Reality: it can be confidently wrong because it reflects the patterns and the flaws in whatever data it was trained on. And myth: AI knows facts the way people do. Reality: it's predicting the most statistically likely answer, not recalling true knowledge the way a person does. Let's zoom out and see the whole picture together. Data feeds into an algorithm. Training turns that into a model. The model makes predictions or generates new content, and that output becomes the real-world impact you actually experience in your apps, your searches, your recommendations. Every AI system you've ever used, from a simple spam filter to ChatGPT, follows this exact same pipeline. So let's recap the key takeaways. AI is machines performing tasks that normally need human intelligence. Machine learning means machines learn patterns from data instead of following hard-coded rules. Deep learning uses many layered neural networks to find complex patterns. Generative AI predicts the next word or pixel based on patterns it has learned. And above all, this is math and data at scale, not magic, which means it absolutely can get things wrong. That's a wrap on how AI actually works. If this helped make things click, drop a like, subscribe for more simple tech breakdowns, and let me know in the comments what you'd like explained next. Thanks so much for watching. I'll see you in the next one.